Hello, this is an update and progress report of the battery capacity tester. This is for the part 4, the testing submission of the project. For this update, the battery capacity tester is inside a package. It's a Ziploc container where the Arduino is secured to the bottom with double-sided Velcro. And then there is a hat on top of the Arduino. I'll disconnect it after a quick demo afterwards. That clicks into the Arduino and has screw-in terminals for all of the connections. And then the circuit is all completed on the this prototyping perforated board here. That's just screwed into the top of the Ziploc. And there's just some cutouts for the USB connection to the laptop and the 9 volts 2 amp power supply. That's just a brick right here, this guy, to power the Arduino. And then the connections for the load and the battery are external to the battery capacitor to the tester, so that the battery and the load can be varied. So like with this power resistor here, depending on what current we want to run, we can just slide the wiper along the power resistor. This is a 20 ohm power resistor. And then depending on the battery you want to use and the constants you set in the Arduino's config for which voltage to discharge to, then a different battery could be connected. Yeah, the project operates, the battery capacity tester operates first by clicking the start button to discharge the battery. And so there's kind of two buttons on the interface for the user. There's a start and a reset. The reset is connected to the Arduino's reset button, so that will reset the microcontroller. So if I just click that, the screen should blink quickly. Yep, and that's just reset. And then if you click start, it should start to drain the battery. And then once the battery reaches below a cutoff voltage, the test would finish and display a a final capacity or calculated capacity. The capacity is measured by by sampling the current running through the load and then multiplying that by the incremental difference in time between those samples. And then if that is summed over time, then you're able to calculate the total amp hour of the battery or a given estimation. Currently the project is set to discharge the battery to a voltage of 12.06 volts, which is around 50% of the capacity of a 6-cell lithium-ion battery. Not lithium-ion, lead acid. And it's discharging to 50% and then applying a multiplier of 2 to get an estimate of the full capacity of the battery. The reason 50% is used is to preserve the life of the battery, because if it's actually discharged completely, it could damage the cells and restrict the capability of the battery's reduce its actual capacity and lifetime. Yeah. You can see that on the display the time of the run, like the run time of the test is there, the kind of running total of the capacity, the current battery voltage, and then the current running through the load. So our load right now is 1.7 amps. On the board on top, none of the components have changed since my original implementation, but you can see here that these are just the connections for the battery plus and minus and the load plus and minus. And then there is a MOSFET here being used as a switch for turning on and off the load. And then a little indicator LED that just lets you know that the battery is being tested and the load's on. On this part of the breadboard is where the voltage monitor is soldered. And the voltage monitor is just a voltage divider that takes the 12 volt from the battery and brings it down to a safe voltage for the Arduino. The voltage monitor also has a couple Schottky diodes going up to the Arduino's 5 volts and down to the ground, just in case there's any surges. Then they won't. They should just run through those diodes instead of hitting the Arduino. Yeah, and so the test finished. That's because I just completed a discharge test on the battery. so it didn't take long at all for it to get to the end, which works well for the demo. So you can kind of see that it demonstrates the total time of the run and the finished capacity, which, as expected, is very low because we just ran a test previously. Here is the current sensor. It's a ECE 723 current sensor, and the battery comes into it and then out, and that's where the kind of out of the current sensor is where the rest of the implementation goes for the load and the voltage monitor. The LCD screen is connected through that kind of female socket there. Yeah, and then the buzzer is kind of tucked there underneath the LCD screen. To calibrate the battery capacity tester, a known voltage and known current is required, and then running the known voltage through the voltage monitor and the known current through the load. Constants can be set for the voltage monitor and the current sensor to make sure you are accurately calculating the capacity and accurately determining the battery's voltage. One difference that I found with testing with the everything soldered together is that there's much less voltage drops, especially with good connections like these terminal blocks and these kind of ferrules on the wires connecting to the battery. Yeah, there's much better connections than the breadboard. The breadboard previously had a lot of voltage drops that were causing me to read a voltage that was actually much lower than what the battery was putting out. Yeah, I think that's it for that part. I will cut the video here and just open up, I'll open up some parts of the battery capacity tester inside so you can get a quick look. Okay, so this is going to be a quick video of the internals of the battery capacity tester. I'm going to start by disconnecting the battery. That guy out of there. Unplug the power supply. So you can see here that the load is connected through these terminal blocks and the battery as well. So all of the connections are connected to the back of this kind of perforated board here, like so, with a bunch of male connections and some wires that are directly soldered to the board. Just I did those for the voltage monitor and the current sensor because I wanted to make sure they had a good connection. And that just comes through a hole in the Ziploc container, and it comes down to the Arduino and the hat. And this hat I can take off as well. Which you can see here has terminal blocks on it and just a bunch of male connectors so it can stick into the Arduino. And these connections then stay there and they don't just slip out. And then in the bottom here is connected with some double-sided Velcro is the Arduino. And that's the package for the battery capacity tester. Also wanted to give a quick glimpse at the LabVIEW interface, which is still the same as it was in the implementation phase, as this part of the project is complete and there was no updates needed. The LabVIEW front panel just has some parameters for the CL connection and specification for the termination character for the data that's being passed serially through the battery capacity tester with the USB cable to a laptop. When you click run, the data from the discharge test is being saved to a text file on the laptop, and also displayed in this small window here, and it includes all of the information collected on every loop of the Arduino cycle. The file can then be looked at afterwards to get any kind of output or utilize the discharge data for anything that's needed after the fact, and for just checking back on the values and your final calculated capacity. The system block diagram, which is kind of the block programming part of LabVIEW, is here. The report gives a good description of the different components required for the block diagram. Thank you. I will follow up this video with a time lapse of the battery discharge cycle. Just because of testing and because the battery takes a very long time to charge with the charger I have, the test only reached to 1400 milliamps, which it is expected to be much lower than this battery is rated for 7.2 amp hours. And that's at a 20-hour discharge test. The test I did was only 30 minutes to 50%, and then a multiplier was added. So the expected value is much less, somewhere around 3000 milliamp hours or 3 amp hours, but we got a much smaller value just because the battery was partially drained. Further testing will be done with a battery that is completely charged once I'm able to charge it again. Okay, thank you for listening, and enjoy the time lapse.